For the first time in human history, a person has received an injection designed to reverse the biological age of their cells. Not slow aging down, not mask the symptoms of it, but to actually reverse it at the cellular level. The company behind this is called Life Biosciences. It's founded by a Harvard geneticist named David Sinclair. They received FDA clearance earlier this year for a therapy called ER100, and they are now injecting it into the eyes of patients who are losing their vision to glaucoma, which is a condition that damages the optic nerve. Did he say inject into their eye? Yep, and I'll get to a reason why in a second. But first, what does reversing cellular age really mean? So the simple version, every cell in your body contains DNA, your biological blueprint. We have all heard about that for decades. But the blueprint doesn't ever change for your entire life. But the way your body reads that blueprint, that does change as we age. It changes in ways that cause cells to function less and less like they did when we were young. You can think of it like a dimmer switch on 1,000 different genes. Over time, some switches that should be on get turned down. Some that should be off start creeping up. And the result is what we experience as aging at the cellular level. But scientists have discovered that certain proteins can partially reset those switches. Not all the way back to infancy, not all the way back to a stem cell state, but just enough to potentially restore youthful function to a cell that has started to decline. These proteins are called OSK, which when introduced into a cell, remind it how to behave like a younger version of itself. So that's what this ER100 is delivering, directly into the retinal cells of a human eye. So why start with the eye? The eye is essentially a contained system. If something unexpected happens, the consequences are limited to that eye. It doesn't spread through your entire body. So for what they call a first-in human trial, that matters enormously. And in the animal studies, the results in the eye were some of the most compelling data that has ever been seen. They reversed the age-related decline in the retina. They completely regenerated the damaged optic nerves. Objective, testable results, not just, the mice seem to see a little bit better. The patients volunteering for this trial already had significant vision loss. For them, the risk calculation is completely different than it would be for someone healthy. So the context here matters. Now, what I've learned about the risks, because you need the full picture here, not just the headline, the history of medicine is full of treatments that looked remarkable in animals and then failed or even caused harm when tested in humans. That is just the reality of how biology works. The concern with this type of therapy, the researchers are using protein that influence how cells behave at a functional, fundamental level. The concern is that those signals become too aggressive, cells could potentially grow in ways they shouldn't. And in some animal studies, a small number of mice have developed tumors. Now, that does not mean that this therapy causes cancer in humans, and from what I've read, the researchers have gone way out of their way to reduce the risks associated with uncontrolled cell growth. This isn't something anyone is rushing into, and that caution is actually a good sign. It tells you that the people involved understand what the risks are. They understand what is at stake. And here's something that doesn't get talked about enough when people bring up AI. We all hear a lot of fear around artificial intelligence, what it's going to take from us, what might go wrong. Right now, 85% of pancreatic cancer cases aren't diagnosed until the disease has already spread. And that's why the survival rate is so devastating. And AI has now changed that equation entirely. And it doesn't stop there. AI is now being used to accelerate the discovery of new drugs. There are over 170 AI-discovered drug programs currently clinically in development. Compounds that would have taken a decade to identify are being found in a fraction of the time. I'm not naive about AI. I understand the concerns, but when I see it being used to find cancer before it can kill you and to help unlock the biology of aging, that's not something I'm afraid of. That's something I'm grateful for. At least for now. So here's what genuinely excites me about this, and I want to be able to separate the excitement from the hype. What's different about this research is that scientists are no longer treating the symptoms of aging. They're starting to explore ways of addressing some of the underlying biology of aging itself. They are becoming proactive. This is a completely different conversation than anything medicine has been doing before. Even if this works perfectly, even if every human trial goes exactly as hoped, we are probably years away from seeing anything like this become widely available, maybe many years. That's simply how medical research works. But the direction is remarkable. Now, here's the part where I want to push back a little bit on something, because I think this is where a lot of people can give themselves an out or an excuse. We see something exciting in a headline about an anti-aging breakthrough, and something inside of us says, well, if a cure is on the way, maybe I don't need to worry so much about the fundamentals. Don't do that. Resistance training, adequate protein, quality sleep, managing stress, staying socially connected, none of that stuff is exciting. None of it makes headlines. None of those things are going to make anyone $1 billion for a venture capitalist. But right now, today, they remain some of the most powerful tools any of us have for improving how we age. I'm going to keep focusing on the habits that are available to me right now, the ones I can control, the ones that are already working, and I would encourage you to do the same. Maybe one day we're going to look back at this moment as the beginning of a completely new era in medicine and in aging. We just don't know yet. What we do know is that the first step has been taken. So the question now is whether the science can live up to the promise. I'm cautiously hopeful, and I will keep you posted. If this got you thinking, drop a comment below, and if you found this valuable, share it with someone else who's paying attention to their healthy aging. They'll want to know about this one, and I'll see you guys next week.